Today, we're diving deep into a tragedy that shows just how dangerous a confined space can be. This is the story of the Cabin Creek Penstock disaster, and it's a tough one. I want you to just put yourself in this situation for a second. You're over 1,500 feet deep inside a mountain, completely surrounded by cold, dark steel. The only things that exist are the narrow beam of your headlamp and the hiss of your paint sprayer. Well, this was the reality for a crew of industrial painters back on October 2nd, 2007. Their job was to recoat the inside of this massive water tunnel. It's called a penstock at a hydroelectric plant in Colorado. And get this, the only way in and the only way out was through a single, small access door, way behind them. And then the absolute worst case scenario happens. A single spark. And in a fraction of a second, the very air around you turns into fuel. A flash fire explodes right between you and your only path to safety. At 2 o'clock in the afternoon, that's exactly what happened. This animation from the Chemical Safety Board shows that terrifying moment. A volatile solvent vapor had slowly, invisibly filled the tunnel, and it finally found a spark. The result was just catastrophic. 5 workers were trapped, they were killed. 3 others were injured. In this explainer, we're going to break down how a whole series of preventable failures created this disaster and what OSHA standards are supposed to stop this from ever happening again. So to really understand what went so wrong, we have to start with the environment itself. That penstock was a textbook example of what's called a permit-required confined space. And that's a classification that comes with very specific life-saving rules. Okay, so what exactly is a confined space? Under OSHA's rule, that's 1910.146 if you're looking it up, it has to meet 3 key criteria. It's not just about being small, it's about having a difficult way in or out, and, critically, it's not a place that's meant for people to be in for very long. And the penstock, it checked every single box. I mean, it was long enough to enter, it had that one tiny entry and exit point, and it was absolutely not designed for people. You see, just recognizing this classification, that is the very first step in safety. This wasn't just a tunnel. It was a known high-hazard workplace right from the start. All right, now for the fuel. Every fire needs it, right? In this case, the fuel was an invisible vapor that had completely saturated the air inside that long, dark tunnel. The culprit here was a chemical called methyl ethyl ketone, or MEK for short. The crew brought about 30 gallons of it into the tunnel. Why? To clean their spraying equipment. Now, MEK is a fantastic solvent, but it is also dangerously flammable, and it evaporates incredibly fast. So every open can was basically turning the air around it into an invisible explosive trap. And this right here points to a huge breakdown of a core safety principle called substitution. Take a look at the flash point of MEK. That's the temperature where it can ignite. It's a shockingly low 16 degrees Fahrenheit. A much safer chemical, xylene, was available, but it wasn't used. That one choice to go with the more volatile chemical just cranked up the risk inside that tunnel to an extreme level. To measure this kind of risk, safety professionals use a concept called the lower explosive limit, or LEL. The easiest way to think about it is as a danger threshold. Once the concentration of that flammable vapor hits 100% of its LEL, you've essentially got a bomb just waiting for a spark. And the rules on this are crystal clear. OSHA says that any atmosphere that's over just 10% of the LEL is considered immediately dangerous to life or health. At that point, the risk is completely unacceptable. Workers have to get out, period. So, how on earth did the air in that tunnel get so dangerous? Well, it wasn't just one single mistake. It was the Cascade, a chain reaction of failures. Let's just trace the dominoes here. First, they bring the highly flammable MEK into the space. Second, the ventilation system that should have been pulling those fumes out was totally inadequate. Third, and this is a huge one, there was no continuous air monitoring, so the crew was completely blind to the invisible bomb they were working inside. And finally, there were multiple sources of ignition that weren't controlled. Each failure just stacked on top of the last, making a fire almost inevitable. And, maybe the most unbelievable failure happened before a single worker even stepped inside. This quote from the investigation says it all. The contractor's safety rating was as 0. They should have been disqualified immediately. But they were the lowest bidder. It's just a horrifying example of what can happen when cost is put ahead of the lives of workers. So when that fire finally did erupt, the last lines of defense, the emergency plan, and the rescue protocols, they just completely crumbled, leaving those trapped workers with absolutely no way out. The timeline tells a tragic story. The fire starts at 2 p.m. The first local responders show up 45 minutes later, but they can't go in. They just aren't trained or equipped for this kind of highly technical rescue. A specialized unit had to be called all the way from Denver, and they didn't get there until 3:40 p.m., a full hour and 40 minutes after the fire began. 45. For 45 agonizing minutes, those 5 men trapped inside communicated by radio. They talked to their coworkers, they talked to emergency services, waiting for a rescue that simply couldn't get to them in time. They died from smoke inhalation about an hour before that specialized team even made it to the site. And here's the thing, OSHA rules are designed to prevent exactly this. For a high-hazard job like this, you are required to have a technically qualified rescue team on standby, right there, ready to go. The plan to just call 911 was a fatal mistake because the local fire department just wasn't prepared for a fire deep inside a mountain tunnel. So what do we take away from this? You know, people say that safety rules are written in blood. This incident is a brutal, brutal reminder of why that is. These rules are the lessons we've learned from tragedies just like this one. So this is the question for every safety pro, every supervisor, every worker out there. Take a hard look at your own procedures. Are you really planning for the worst-case scenario, or are you just ticking a box on a form? Is your air monitoring continuous, or is it just a quick snapshot before you go in? Let's be absolutely clear about one thing. The 5 men who died at Cabin Creek, they did not have to. Their deaths were 100% preventable, with proper hazard planning, using safer materials, continuous monitoring, and having a real rescue plan in place. Confined spaces are still one of the most dangerous places you can work, but they don't have to be the deadliest. If you want to learn the standards and strategies that actually save lives, we really hope you'll subscribe to HSestudy. Our whole mission is to give you the knowledge you need to stop tragedies like Cabin Creek from ever happening again.